Hello, this is Professor Stephen Neshiba, and I'm here to help you out in this video with some of the questions in Chapter 9 that have to do with molecular orbital theory. And so I'm going to start us off. I just have a few slides here I'm going to show you. This slide here you're already familiar with. It's sigma and sigma star molecular orbitals from overlapping atomic s orbitals. And as you well know from your Spartan work, here we have constructive interference between those two atomic orbitals that led to a sigma bonding molecular orbital. And up here, I've shown in the dashed line, destructive interference between those two atomic orbitals leads to a sigma star antibonding molecular orbital. How about when we start building molecular orbitals from atomic p orbitals? Well, turns out we can make sigma and pi type MOs from here. So here's an example of forming a pi molecular orbital. It's constructive interference between these two standing up kind of p orbitals to produce that pi orbital. And here we have destructive interference between these other two ones to produce a pi star antibonding orbital. Now upstairs here, here's two end-on-end p orbitals that have, as you can see, they can constructively interfere right there to produce this bonding orbital, but it's a sigma orbital now. So one question, 9.83, says, do all sigma molecular orbitals result from the overlap of s atomic orbitals? Well, no. Here's a sigma MO that resulted from the overlap of two p atomic orbitals. So we can go on here a little bit to what can happen with d orbitals, and as you might expect, d orbitals are kind of complex enough that we can line them up in a sigma way. That's what this is, end on end. We can line them up in a kind of a pi way, so you can kind of see constructive overlap there, constructive overlap there, and this is two more d orbitals that are on their side, but these are also producing a pi kind of molecular orbital. And here we have this even stranger one. We have 4 different opportunities for constructive overlap between these two. And let's see, so I've just kind of highlighted here that constructive interference here has led to pi bonding MOs, and that's addressed in your problem 9.84, where that asks, do all pi orbitals result from the overlap of p atomic orbitals? Well, no. Here we have a pi orbital that has resulted from the overlap of two d orbitals. Let's see, oh well, what's missing from the previous slide are antibonding orbitals, but you can well imagine that if you line up two d orbitals but in a way that there is not constructive interference, it's destructive interference, then what do we have? We have a pi star antibonding MO that happened from the overlap of d orbitals. And and then the last little bit of the story is we don't have to just interact d orbitals with d orbitals or p with p. Here we have a p orbital that's on, say, one atom, and it's approaching a d orbital on another atom. And if I said that blue is in phase with, that it can, or this aqua can constructively interfere with blue, and the white lobe constructively interferes with red, then what do we have? It looks like we're going to have a pi bonding orbital that resulted from the mix of a p and a d. And a similar kind of story here, where we have destructive interference producing a pi star antibonding MO from a p and a d.